All right, so let's get this started. So first off, I want to wait. Yes, I want to congratulate everyone on the happy 10 years of Elixir. Unfortunately, I am participating virtually this year, but I hope everyone at the event is going to have a great time with the celebrations. And for us who are virtual, we'll celebrate the happy 10 years of Elixir with Elixir 1.14. So the goal is for every time there is a new Elixir release, I like to show this very quick summary, right? I think I have one slide like this for pretty much every Elixir release out there. So we hope to release it this week. We're just like putting the final dots on the i's. And we are about 1,145 contributors, more than 50K packages on hacks, which have been downloaded more than 8 billion times, right? So this is pretty exciting. And when we are going to talk about Elixir 1.14, as usual, we have a changelog. There are a bunch of exciting features in there. But for the presentation, I want to highlight the ones that I am most excited about. And so today we're going to talk about DBG, Partition Supervisor, the expression and order-based inspection, and improved error messages for binaries. All right, so let's get started. So DBG, who here has done like IO inspect debugging, right? I've certainly have done that. Possibly today morning, I've already did some IO inspect debugging. And the thing is, imagine that you have this pipeline, right? Like you have Elixir School, you're training, you're splitting the words, you're doing something with this pipeline, and the result is not exactly what you expect. Usually, if you debug anything like me, you would go and add an IO inspect somewhere where you think where the bug is, and then it's like, wait, no, this it's not here, right? So you go, you add an IO inspect somewhere, and then you start adding IO inspects to your code, and then it gets to a point where like, wait, I don't know this output, which IO inspect is related to this output. So you come back, you add some labels, right? So we want to improve this workflow in several ways in Elixir 1.14 with the addition of DBG. So DBG works like IO inspect in the sense that you give it like an expression and it's going to return the value of that expression. So you can use it in pipelines. But the cool thing about DBG is that DBG is a macro. So as a macro, when it prints the value, like in this case, it's going to print the value showing what is the file, what is the line, if you're inside the function, potentially the function, the module, and it's going to print the source code as well that it's debugging and the value, right? So the good news is that now you don't have to go back like and add the labels, for example, right? Because we are adding a lot more information by default. And the interesting thing is that DBG was actually proposed by a coworker of mine, Wojtek, I think 3 years ago. And you can find it on the mailing list. And back then I said, well, if all DBG is doing is just adding this like additional information, that's useful, but I don't think it's like it's a deal breaker. Like it's important enough to make it part of the language. So what changed? What changed is that DBG actually has superpowers. So DBG has two superpowers. So first, because DBG is a macro, it understands your code. So now, for example, if you have a DBG, if you have a pipeline and you put DBG at the end of the pipeline, we actually know that that thing is a pipeline, and we will we can automatically print each step of the pipeline for you without you having to add more DBGs. We can just look at the code and understand it. But furthermore, DBG supports custom backends. So maybe you are in an editor, maybe you're using IEX, and maybe you want to debug and you can do something a little bit different or a little bit smarter. So to show how the superpowers work together, I have a quick video here. Let's see if this works. So this is a terminal session that Andrea recorded, and you can see here that he has like this DBG access file, and it has a single pipeline in here. Okay, it's a single pipeline. So what it's going to do is that if he executed this with Elixir, the DBG would print the values of the pipeline. But because he's using IEX DBG, because IEX running, what is going to happen is that as soon as IEX finds a DBG, it has a custom backend. It's going to say, hey, do you want to pry? And pry is how we drop an interactive shell somewhere, right? It says like, hey, do you want to pry this pipeline? And if you say yes, now you are there in the context of that code, right? You can see I am there in that code. You can access the variables of that code, right? You can access things as usual. But not only that, you can say, hey, you can use N for next, and then you can go to the next step of the pipeline, and it's showing the result step by step to you. Okay, so this is where you can see like the true superpowers of DBG working together and bringing a better experience to when we have to debug our code. So yeah, that's DBG. We hope it's going to be really useful. And first of all, it's already shorter, right, than IO Inspect. So just for that is worth it. But when we are debugging, but I hope you are really going to enjoy those additional features, and they are going to help you shape and change how we debug code. So another feature in Elixir 1.14 is the idea of partition supervisor. So it's a new type of supervisor. And the use case for the supervisor is the following. So imagine that you have this code in your application. You define a dynamic supervisor somewhere, you give it a name, and then in different parts of your application, you're like, hey, I want to start a child under this dynamic supervisor, right? And there are many, like, so for example, when you're serving like Phoenix, right? Every time there is a request, there is something starting a process in the dynamic supervisor. Or every time you connect to a channel, there's something starting a process under our dynamic supervisor. However, there is an issue with this code, which is that if like a supervisor, when it's starting a child, that supervisor is blocked while that child is starting. And usually starting a child is fast. But for example, imagine that you are starting a child, and what that thing is doing is like doing a query on the database. That can start taking time, which can make it so that this dynamic supervisor becomes a bottleneck, right? So in order to solve, we have like, I have solved this problem like in a couple different places. We have solved like, so for example, sorry, in Phoenix, we have like our own implementation of a, like we did not want to have this bottleneck, so we would start like several dynamic supervisors. Acto, I think, has something. So like I have implemented like this pattern, like trying to remove those bottleneck in a couple different places until I said, okay, it's enough. We have to make this absolutely easy to do, like to make this dynamic supervisor scalable. So in Elixir 1.14, we have now the the partition supervisor. And what you do in the partition supervisor, instead of saying, hey, I want to start a dynamic supervisor, you say, I want to start a partition supervisor, and we are going to say that the child of this partition supervisor is going to be multiple dynamic supervisors. So by default, the partition supervisor is going to start as many dynamic supervisors as you have the number of cores. So if you have 8 cores, going to start 8 dynamic supervisors. And now, whenever you want to start a child, instead of saying, hey, I want to start in this dynamic supervisor, you're going to say, I want you to go to the partition supervisor, and the partition supervisor is going to pick a dynamic supervisor to start on, right? So it's basically partitioning, starting a bunch of dynamic supervisors, and you're going to pick one based on the partition key. And in this case, we can make it so the partition key is the current process. So every process is going to pick a random dynamic supervisor to start the child, right? And that's it. It's like it's a very simple usage. You just say, hey, I want to start something under the partition supervisor. And now when you say start child, you say, I wanted to pick something. When you are going to talk with a process, you are going to say, I want you to pick something via the partition supervisor. And I think the most common use case is going to be via the dynamic supervisor, but you can partition any process where you can start multiple partitions that are independent of each other. Like if you can partition their state, you can think like each dynamic supervisor here is a different process with a different state. So as long as they have like different states and they don't have to communicate, the partition supervisor is going to make it very, very easy to scale. Um, yeah. Another, I'm not even sure if I'm going to call it a feature. I would say one change coming in Elixir 1.14 is that we are giving a try on expression-based inspects. So what are we trying here? So imagine that we have map set, which is a set data structure that we have in Elixir. And then you create a set with like true fruits, and then you put apple. And then when you see these things represented in your terminal, right, what we're going to see is this thing here with a hashtag, right? And the reason why we put the hashtag in front is to say, hey, this is not valid Elixir code. If you get this and you copy this into your editor, into your task, whatever, this is not valid Elixir code, right? You can't really access the data structure. And this is quite annoying, right? Because sometimes we want exactly that. We want to get a value that we see on inspect, on the test results, on the log, and you want to play with it, but we can't. So what we are trying in Elixir 1.14 is to use an expression-based inspection, which basically means that we are going to print the map set like this now. Let's say map set new. And that's valid Elixir code. We can now get this, you can put in your editor, you can execute it, and it's going to work. Okay. So we are trying this for a couple data structures where this makes sense. We have rewritten the documentation of the inspect module to say when this new approach makes sense. I know some projects like Decimal, they have already moved to this representation, so we will be really eager to collect feedback from the community. Related to inspect, one change that we have also done in this release is to make it so when you inspect a struct, we follow the order of the fields as they are declared in the struct. So for example, imagine that you want to print we want to inspect a URI. So we write this code, URI new, and then we build this URI, okay? So the Elixir team was talking about, hey, like, should we use the new like expression-based inspect? And they were like, well, that would be nice, but the downside of using the expression-based inspect is that we hide the internal fields of the URI, and those fields, they are public, right? We don't want to hide them. Those fields are public. So, but then we were looking at this representation, like this is not really a good representation, right? Because like it's hard for you to look at this representation and build the URI back because the fields, they are all out of order, like the scheme, which is the thing that you would look first, right? It's here. I cannot select it properly. It's right here in the bottom, right? So this is not really helpful. So we thought, wait, what if we could control the order where the fields that we are going to print when we inspect them, right? And that's what we can do in Elixir 1.14. It's going to, by default, follow the order in the dev struct. And now this is much better, right? Because it's the order of the fields as they appear in the textual representation. So it's much easier for me to mentally build back what this URI is. And then you can start thinking about this and applying this to other things. So for example, imagine you're working with Acto in your application, right? Most of the times, like the first field that you want to see is the ID, right? Because the ID is really important, right? It's the thing that kind of identifies the thing, right? And now it can appear in the middle, it can appear anywhere. But now if the dev struct ordered inspect, we are going to show the fields in the order they are declared in your schema, okay? There's one caveat here. Because before we did not respect the order, older Acto versions, they are going to show the fields in reverse order. So it's like the timestamp is going to be first because we never use the order for anything. So if you upgrade your actual version flow, it's going to be the order in our schema, and it should be good. Okay. Another change, this is a quick one, another really big change in important change in Elixir 1.14 that we have improved the errors for binaries. This is really thanks to the OTP team. So last year, the OTP team, they posted this Erlang enhancement proposal that we called EEP. They posted EEP 54 about improving the mechanism for errors in Erlang, and that made it really possible to improve in general error messages in Erlang. And there was only one part that was missing, which was improving errors for binaries. So before, if you try like to concatenate two binaries, this is what you would get, right? We just say, hey, argument error. But now, if we use OTP 25 and Elixir 1.14, you get the whole thing, say, hey, what actually failed was the construction of a binary. And the first part, the int, we expect that thing to be a binary, but we got one, right? So this is much, much better. And there are many other improvements in this release. Again, consult the changelog for the whole list. But we have also like improved error messages during evaluation. So usually Elixir code is compiled, and we have really good error messages in there. But if you're using IEX or Livebook, for example, then we are evaluating code. So we have spent some time improving the error messages during evaluated code too. Another change in this release is that 2 or 3 releases ago, we added this stepped ranges. So before we could say, hey, I have a range from 1 to 9. And that would include 1, 2, 3, 4, up to 9, right? But now we have stepped ranges where you say I have a range for from 1 to 9 in steps of 2. So it would be 1, 3, 5, 7, 9. And we added this feature, and now we finally have gone through all the standard library and make sure that things like in num slice. So this num slice is something that where we can give like a list and say, hey, I want from the second to the 10th element, right? We went through those things and make sure that it supports steps. So you can say, hey, I want to go from the second to the 10th in steps of 2, for example. The same for strings. So we are supporting these steps now in whenever we can in the API. Speaking about slice, we had enum slice, which works for lists and enumerables. We have string slice that works with like strings considering Unicode, but we didn't have a function for like slicing a binary, slicing the bytes of a binary. But now they are here, binary slice 2 and binary slice 3, mirroring the APIs that we have in the num and string. We have also added multi-line comments in EX with Phoenix Live View and Hicks pushing the boundaries of EX. It became clear that we need proper API, proper syntax for multi-line comments in EX, and this is done mirroring the HTML syntax. So this is in 1.14. And finally, we added a mix eval, which is meant to mirror being release eval. So the idea here is that when you build a release, if you want to execute custom code in that release, like programmatic via the command line, you have to create like you do it through eval. You say being my app evolve this thing. So we create modules that are meant to be evolved, right? That's how we are approaching those things in releases. But the issue is that those modules, there was no easy way to call them from Mix. So now we added Mix Evolve, which is meant to mirror being released. So if you want to create a module and you want to use it or from a release or from Mix, you can do that using a very similar API. The Mix is going to emulate an environment that is close to the releases, so it's easier to test and so on. All right, that's what I had to share with you about Elixir 1.14. And I want to take now the rest of the talk. I have 20 minutes to talk about what is next. Okay, so what is next for Elixir is pretty much what we have been seeing, like what we saw in this release and what we have seen over the last 2-3 years. We'll continue releasing new versions every year. It's usually between 6 to 9 months, right? There's a new version out. And those versions, it's like Elixir 1.14, it's a perfect example, right? It has improvements. We are improving or making things faster or adding small enhancements here and there, but it's nothing really that is like turning our world upside down, right? The goal is to like is to keep everything stable, right? And this has been, I have to say, like very refreshing because if we go back like 5 years ago instead of 3 years ago, if you go back like 5 years ago, the Elixir team was really busy working on things like code formatter or mixed release because the community would be like, hey, we are adopting Elixir and our team is starting to grow like really big. We have like 70, 80 engineers, and we really need a style guide or we really need a code formatter. So we collected this feedback from the community and we acted on it, right? Same thing, like people say, well, deployments in Elixir is not really great. It feels like it could improve a lot. So we worked really hard on mixed releases and we have been refining this. But with the major pain points from the community being addressed, now the Elixir team has a lot more time to just like go out of our comfort zone and start like exploring and playing with different things and different ideas that we would not have time for otherwise. So with this intent, 2 months ago, I gave a talk at ElixirConf US Europe called My Future with Elixir. And I said that my future with Elixir, the things that I am personally excited about, they are three main areas, okay? So the first one is set theoretic types for Elixir. The second one is developer and learning experience. And the third one is machine learning. So in that talk, I spent most of the time, I spent really the whole talk talking about set theoretic types for Elixir. And we are going to quickly rehash here, but then we're going to go to the next points, okay? So, so for those who haven't heard the news, I've made an announcement where we have now a PhD scholarship to research and develop a gradual type system for Elixir, which are backed by set theoretic types. Guillaume Duboc is the PhD student. He's being supervised by Professor Giuseppe Cassanha, and I'm also involved in this project. And if you're asking, wait, why set theoretic types? Do we even want to have a type system in the first place? I've answered all those questions and potentially more during my presentation. So I recommend watching out this keynote and exploring this topic. For now, on this topic, I just want to thank once again the companies that are making this happen. So this scholarship is a partnership between the CNRS, which is the National Center of Scientific Research in France, and Remote. And it is being sponsored by Superbase, Fresha, and Dashbit. And I know that Superbase and Fresha, they are sponsoring. Sorry, yes, they are sponsoring. What I mean to say is that they are hiring. So if you're looking for new Elixir opportunities, be sure to reach out to them. And that's it that I'm going to talk about this topic. Please check the presentation, and hopefully a big chunk of your questions are going to be answered there. So let's go back. Three main areas of focus. Something that we have been working on really, really hard to improve the developer and learning experience. And I actually wrote a bunch of slides explaining some of the things. And I said, you know what? I think like the best way to show some of those ideas is to do a quick demo of Livebook. So for those who are not familiar, Livebook is it's a web app. It's an open source web app that allows you to write like interactive and collaborative code notebooks. So I'm going to share my screen now, and I hope this is going to work out fine. So here I have, if this is not working, Jim, or just say something, give me some feedback, but I'll assume this is working fine. So here I have like a notebook running inside Livebook. Livebook has a desktop app, so you can download it and install it and run it on your machine right now. And a code notebook, it's basically a way of mixing like documentation, like markdown documentation, like here. Well, let me add something. And code, right? So here I can write any Elixir code. And now I have like those two things side by side. And the cool thing is that here we have a code editor, and it's like a quite complete code editor. Like we can start typing, we get auto completion, and then we type the function name. And when we are inside the function name, we can see the signature. We can mouse over things and get the docs right here in the editor. So there are a lot of cool things happening in this editor, and all those things, they're being powered by new Elixir features. Um, we added this thing called code fragment, which is a way for Elixir to understand like partial pieces of code, so we can give like those tips and those hints, right? But one of the cool things, so this is the editor, but one of the cool things about a Livebook is that it really starts to make us think more about visual representation and visual thinking. And in the last like a year and a half that I have been working with Livebook, this has been like very liberating. And I want to show some examples, okay? So imagine here, like imagine that we want to teach somebody about processes. We're going to say, hey, we can do self, and self is going to return the identifier of the current process. And then you can, as you're teaching this person, right, you can say something like, look, I have the I'm going to assign the current process to a parent variable, and then I'm going to start a child, and I'm going to start a child, and what this child is going to do is that it's going to wait for a ping message, and then it's going to send the parent a pong message, and then we can see here that the parent's going to send the ping that the child is expecting, and then it's going to receive the pong that we are expecting the child to reply with, and then we're going to return pong. So if I execute this code, I get pong at the end because it worked exactly as I described. But wouldn't it be better if we could actually see this, like, like have a visual representation of those messages going back and forth? So so Livebook is like, it's the server, it's the web application, but we have this thing in Livebook called Keynote, and Keynote is something that runs alongside your code, and it animates Livebook. It tells Livebooks about like visual representations and a bunch of other things that we're going to see really soon. So if I say, hey, I have this Keynote process and I want to render the sec trace. So it's the same code I just wrapped in this function. What this is going to give to me now is this. It gives me this like diagram saying, hey, I have self here. It spawned a process. It sent a ping message and it got pong back, right? So we can actually start seeing these things. And it's not only about like teaching. It's not only about teaching developers how to program. Like, so for example, Elixir has this feature called task async stream. And what task async stream does is that it, for every item in the collection, it starts a separate process to process that item, so we can do those things concurrently. So actually, instead of sleeping random, let's say we're going to sleep, each process is going to sleep a given amount of time based on their number, from 1 to 4. So if I execute this code, what you're going to see here, like, as an Elixir developer, if you're an experienced Elixir developer, you most likely use task async stream. But if you want to build an intuition into how it actually works, like behind the scenes, you can just wrap the code in render sec trace, and now we can actually see things, right? You can say, look, what we were expecting was it would be self plus 4 processes, right? But we can see here that it's actually self and 5 processes. And then when we look here further, we can say, look, it seems that we start a process to act as a coordinator, right? So we start this process to act as coordinator, and now it spawns a child process, and now every time we want to process a new item, the coordinator say, hey, I spawned this process, send the information that you want to send, right? Send the information that you want to send to that child process, and it's going to process it. And you can see here, because I'm saying, look, each process is going to sleep I multiplied per 10. You can see how they cascade here, right? And yeah, so we can start like building this intuition of how those processes are communicating and how the code is going to work. And we can actually go back here and say, let's use the random, right? Say, well, because if you're using task async stream, for example, to talk to an external API, what would happen is that the API could send responses in different times. So we can actually simulate it here with a random sleep. And then you can see now, like, the 4th process was really fast, right? The first one apparently took super long. And we can start emulating and really seeing those things and visualizing those things, okay? And it's not only about process communication. Maybe we are teaching somebody about a supervisor. So what if we could go right here and say keynote process render supervision tree, and it renders a supervision tree for us. But even better, wouldn't it be cool if if Livebook automatically detected that you are printing a process, right, which is a supervisor, and then it says, look, this is the raw representation, but you can just click here and you can see the supervision tree. So now we are no longer, we don't even expect people to know that this magical keynote process render subtree function exists, right? They no longer need to know it's discoverable because they can just have, say, return a supervisor, and the supervision tree is going to show up. The same thing for the application tree. So kin is an application. I can render the application tree, or I can make it so every time there is an atom, and this atom represents an application tree, we can just click here and see the application tree. The same for an atom that represents a supervisor. I can just click here and see the supervisor. So I hope you're seeing the idea, like how you're starting to see things visually and start to apply visual concepts. And now that we added DBG to Elixir, right, we're starting to think, wait, how would DBG then work inside Livebook, right? Because now we can start thinking about things visually. Maybe it could be like a breakpoint debugger, but I think we can actually have a richer experience than a breakpoint debugger. So now if I have like DBG and I'm inspecting a pipeline, when I execute this, we can actually show the pipeline. Say, hey, I have DBG on line 5, and here's the pipeline, and I can actually click and see the result of each entry in the pipeline, right? And then maybe you're looking and say, oh, I know what is debugging this code. Is because if I write this, I want Elixir to be without the bank. And now I can come here and say, oh, I think I know the fix. I think the fix is that I should get this string trailing thing, and I want to move it at the bottom. And then I can see the output. Oh, yes, it's without the bangs, exactly what I want. I can compare it with the actual output. So I can click here, copy the new pipeline, and I can paste here. And now I have my fixed code. Okay, so again, the idea of starting to think visually. And we can start applying this more and more. So for example, imagine that, I'm running out of time. So imagine that you say, look, there's an issue in production, and you are like, I have to debug this. And the first thing I would do is that I would run Observer, and I would run like the Phoenix Live dashboard. That's the first thing I would do, for sure. But imagine that you run the dashboard, you run the Observer, and that's not enough. You can say, hey, what if I start collecting information about the processes, and I plot them in a chart that has the number of reductions, which is how much work the process is doing, compared to how much memory this process is taking. Maybe this is going to give you new insights about what are the processes that are actually really busy in your system, right? Or for example, we know that we can get how the memory is allocated inside the Erlang virtual machine by doing Erlang memory. So what if I could build a chart and plot those things over time, right? So here I'm plotting over time how the memory is being allocated. So now I can do experiments. I could maybe call a code for my application and see how it's going to affect memory over time. So here as an example is, well, what if we allocate a bunch of strings really, really fast, right? We can see that we have a spike here in the binary allocation, right? And it goes down because we are not storing those strings anywhere, right? So it goes back down immediately. But we can say, well, what if we are storing things on ETS? Because now it's ETS, it's permanent, right? It's stored there. What is going to happen is that memory is really going to spike and it's going to stay high, right? Like the ETS increase because we just put a bunch of things in ETS. So we start thinking more about the visual representations. So there is one last thing I want to talk about here, which is about smart cells. So I'm saying like, hey, we can start thinking more and more visually, right? But there is an issue in here. There's a chicken and egg issue, which is for us to get all those things, all those nice features, we have to be writing code. We have to know like how to plot graphs. We have to know how to push data to graphs. We have to know all those things. We have to know about keynote process unless we are tabbing. How can we break the cycle? And that's the idea we have with like smart cells. So imagine that you want to do a new task, a new workflow. So for example, imagine somebody says, hey, you are starting working with Elixir, and somebody says, look, I wanted to generate a script that is going to connect to the database, and generate a report. And then you're like, cool, I know how to connect to a database inside my Phoenix application because it uses Acto, but how I'm going to connect to a database like out of nowhere? So I can actually come here to a smart cell and say, look, I want to create a new database connection. And it's going to print like this widget. And then we can put information here, like I have a demo dev database, and my user is the default Postgres user. And now I can actually go and execute this, and it gives me a database connection. But the cool thing, and it's assigning that to the connection variable. But the cool thing about smart cells is that we can actually see the code. So I can actually just click here and see how I should actually connect to a Postgres database in my Elixir code. I just need to add the library, and this is the code that does it, right? And so now it can really work as a learning tool, and we can start applying this to a bunch of different places, right? Because you can say, well, maybe we want to teach somebody about how to do an HTTP request. We can write a smart cell that allows you like to build the HTTP request, put in the URL, put in the headers, and then you're like, okay, show me the code that actually submits the request. You could click on toggle source and actually see the code. One last example. Well, so imagine like we want to build a chart, okay? So we want to build a chart of the processes, which is the chart that we saw up here, right? So I can ask the tool, hey, to show me how to build a chart. So I have here a chart, and it says, look, the data that I have are the processes. It's the only chartable data that I have in this notebook. And on the x-axis, I want to have reductions. On the y-axis, I want to have memory. I want, and then I can already start rendering this, right? So all the points are cluttered. So I can increase the graph a little bit. Maybe it's going to make it better. It's an improvement. And I want to add the color to those points based on the status. So if the status is running, it gets some color. If it's waiting, it gets another color. And you can see that we are getting there, right? But there's an issue, like all the points are cluttered here, which means that whatever scale that we are using here, it's not good enough. And this chart doesn't allow us to customize the scale, right? But what we can do is that we can look at the code, or even better, we can say, look, I wanted to convert this smart cell into code. And when it converts into code, you can execute it. You can get the same thing. But actually, now I can go here and change it. And when I go here and change it, I can go to the documentation of this function and learn that there is a scale type log thing that is exactly what I need to go back to that other graph. And I was able to reproduce without like not really knowing much about how the Vigalite library works, right? I was able to reproduce that same chart. So anyway, there's really a lot to talk about here. I'm going to go really quick. So other things to have in mind is that we have integration in Xdoc. So if you have like live MD files, which is how we save notebooks, if you put that in your project, it's going to generate them inside Xdoc with the running Livebook button that you can click and start running that notebook. The other thing is that we have this amazing event called Spawn Fest, where you have two days in the weekend to hack on Erlang Elixir libraries. And we have a Livebook category too, either to implement smart cells or to implement Livebooks. So check out the event, not only the Livebook part, the event altogether. And the last thing that I want to talk about, that I should talk about, is machine learning. But gladly, we have a growing ecosystem here. There's a lot to talk about. But the good news is that there are two people speaking at the event that are way more capable of talking about those things than I. So I recommend checking out Sean's Moriarty talk on Axon, which is the neural network library, and Chris Granger talk on Explorer and how they are migrating their ETL and machine learning pipeline to Elixir. Thank you very much, and I hope you have enjoyed it and you're excited about all those things that we are building and excited about thinking visually. Thank you.